Lesson 27. We have two topics happening today. The equation of the tangent line and higher order derivatives. Okay. Higher order derivatives, you'll definitely like, you'll be fine, So equation of the tangent line is a little bit different. If you recall, when I very first time introduced derivative, you guys remember the definition of the derivative? Not like the equation, but what the derivative is. Okay. The derivative is the slope of the tangent line. Okay, we talked about that back in whatever lesson when I first introduced derivative. At that time, it was definition of derivative. But derivative is the slope of the tangent line. So the slope of a line tangent to a curve at a designated value of x can be found by evaluating the derivative at that value of x. Okay, so slope of tangent line, derivative. Correlate those in your mind. You've got to know that when you hear one, it insinuates the other. So the slope of a tangent line to a curve, one thing I've written in here. So like if your curve is f of x, it can be found. Oh wait, that's for. Okay, hold that thought. That wasn't what I was. I'll come back to that. But the curve is f of x, then the derivative is at f prime of x, right? Okay. Look at example 1. They give us the equation. Let y equals x squared minus 4x plus 3. Compute dy dx at 3. So what this is saying, y equals x squared minus 4x plus 3. This is your initial function. So this is where this was going. This is my f of x. They're asking me to compute. Now dy dx, what does dy dx mean? That's one of our ways of saying derivative. 3, what that little line means is it says at, or evaluated at, x equals 3. So what this is saying then is that we're going to find f prime of 3. So we're going to find the derivative and evaluate it at 3. And when I say evaluate, I mean put 3 into the equation. Okay? So, if y is x squared minus 4x plus 3, this is old news, derivative. So I want to find dy dx, the derivative of y with respect to x. So the derivative of the y equation in regards to the x variables that are in there. So what's the derivative of x squared? 2x. Because you bring the 2 out front, and then you subtract 1 from the exponent, right? 2x. What's the derivative of minus 4x? Minus 4, because remember this is an invisible exponent of 1. So you bring the 1 out front, it's still minus 4. 1 minus 1 is 0, so the x no longer exists. And what's the derivative of 3? 0, because any derivative of a constant is 0. So this derivative is 2x minus 4. They want me to find dy dx at x equals 3. Which means what am I going to do? Plug in 3. 2 times 3 minus 4 is 2. So what that means, excuse me, given this equation, x squared minus 4x plus 3, so this is a parabola, right? When x equals 3, the slope of the tangent line is 2 at that point. Okay? Because when you have that parabola, you can draw tangent lines any place on them. They're not all going to be the same because it depends on where you're at. But the slope of the tangent line will be 2. No, the slope would be 2. The slope would be 2 at x equals 3. Okay, so at 3 something, whatever ordered pair that is, the slope is 2 at that point on the graph. Okay? So the idea, it's a parabola, yes? A slope of 2, I don't know, might happen here. So that tangent line, like there's the tangent line for that point. So we're saying the slope of this line is 2. And then the x value of this point is 3. It's 3 comma something.
So obviously look for one example, what you mean by slope?
Yeah, slope. Yeah, like traditional slope. So not the slope of the curve, because as I move and find a different point here, now my tangent line is that. If I go back here, my tangent line is that. So that's, it's constantly changing as you go around that curve. Okay, example 2. Find the equation of the line tangent to the graph y equals x squared minus 4x plus 3 when x equals 3. So we're finding the equation of a line, yes? In order to find an equation of a line, what do you have to know? The slope and the y-intercept, or some kind of point on the line, right? You have to know a point and a slope. What's our favorite equation of a line? Y equals mx plus b. So that's going to be my final goal, is to get an equation in the form y equals mx plus b. Now, how can I find a point on the line? What did they give me to begin with? X equals 3. So that means a point on the line is going to be 3 comma something. How do I find my something? Plug it into what? Okay. In what equation, I guess is what I'm asking. The original equation, yes? If we want to know that's 3 what, so in other words, what I'm trying to find right here is the point on the line at x equals 3. In order to do that, I'm going to do y equals 3 squared minus 4 times 3 plus 3. Do the math. 9 minus 12 plus 3, which is 0. And so this ordered pair is 3, 0. Now, that's my point. What else do I need to write the equation of a line? I need a slope. How can I find slope? What we just did up top? That just so happens to be the same stuff. Okay, so it's the idea, and I'm just going to rewrite it right here. dy dx, we already found to be 2x minus 4, right? The derivative was 2x minus 4. And then when we put in 3, we already found that to be 2, yes? This is me just rewriting the basic steps. Whoops. The basic steps, so we have it here. And so what is this 2? This is the slope when x equals 3. Okay? Can we use that information to write an equation? Yeah. How do you guys want to get your y equals mx plus b equation? Okay. One option is to use point slope, which I'm all for. I don't remember what this class prefers to do as a whole. The other option is, can you fill in m, x, and y and find for b? What's your guys' preference? Fine. I was kind of thinking that some of you still like that, which is fine. If I plug in y, so 0 equals m, which is 2, times 3 plus b. So 0 equals 6 plus b, and b is negative 6. So what's my equation? y equals 2x minus 6. Okay, so if they want the equation of a tangent line, first of all, you need a point. They'll have to give you an x value, so then you just find the y value, and then you also need to find slope. Slope is derivative. Derivative of the tangent line is slope. Excuse me. Derivative is slope of the tangent line. It is. How many times did I say it wrong there? Okay, ready to try example 3 then?
Yeah.
I mean, technically, we're taking what we know about derivatives and slope, and then we're doing algebra 1 skills. You may not see it like that, but really we are. Find the equation of the line tangent to y equals sine x when x equals pi over 6. So again, it's an equation, right? What do we need for an equation of a line? 2 things, a point and a slope. So we need to know something about the point on the line when x equals pi over 6. So how do I find that point on the line? Yeah. Right now I know my ordered pair is pi over 6 comma something. Plug it into your original equation. So if it's y equals sine x, y equals sine of pi over 6. Think chart. What is sine of pi over 6?
I don't know it off the top of my head. I always just remember the triangles and then make the chart. So
Okay. It's 1/2. Because pi over 6 is 30. So sine of 30 is that top left corner in my chart. And so that is 1/2. So what's my ordered pair? Pi over 6 comma 1/2.
I knew it was 1/2. I just wanted to give Wade a chance to look back at it.
So nice. Okay, I have a point on the line. What else do I need? A slope. How do I get slope? Before we can do that, though, we have to get the slope. To get the slope, we need to find the derivative. If y equals sine x, then what's dy dx equal? Just cosine. Yep. And it's easy to do. You just have to work on ways to remember for you. So the derivative of sine is cosine. So dy dx equals cosine x. And where do we have to, what are we doing then? The derivative evaluated where? When x equals pi over 6. So the derivative evaluated at pi over 6 means I'm going to be doing the cosine of pi over 6.
Is there one way to do it on this one?
No, we have to, this is one, it's in the chart, so you can go one more step. Cosine of pi over 6. Okay guys, pi over 6 is like 30, yes? If sine of 30 is that first box and it's 1/2, what's cosine of 30? Radical 3 over 2. Okay? So this right here, the derivative at pi over 6 is radical 3 over 2. And so what is this? This is my slope. This is the slope at x equals pi over 6. So what do I do to write my equation now? Okay. Either y equals mx plus b or y minus y1 equals m times x minus x1.
I just found a key from the second test.
So y 1/2 equals m radical 3 over 2 times x, which is pi over 6, plus b. So 1/2 equals, yeah, you can't really clean it up a whole lot other than pi radical 3 over 12 plus b. How do I solve for b then? Subtract that fraction thing.
Yeah.
So then b is going to be 1/2 minus pi radical 3 over 12. As far as I'm concerned, you can leave your b like that. That is fine. So, final answer. Y equals mx. What's m? Radical 3 over 2 times x plus b. What's b? Plus 1/2 minus pi radical 3 over 12.
That's a mouthful. It's not looking too bad.
This is the hard stuff today, what we're doing right now.
Really?
Yes,
Problems?
the backside is easy. Are you okay with all the derivatives we've done in the past?
Yeah.
Okay, the backside is all about that. So, this is the harder part, which to me, this is not that hard. It's using our Algebra 1 skills. You just have to kind of put it all together. So, I mean, we've done a lot harder stuff than this is what I look at, I guess.
I kind of like it when they do the hard stuff first and the easy stuff.
Okay, example 4. Last one of this type. Again, it says find the equation of the line tangent to y equals sine x when x equals 1. Okay. Take me through it.
Alright, so we need a point and we need the slope.
Okay. So let's start with point, please.
Point of 1.
What's the rest of that point?
We don't have.
How do I find it?
We gotta.
Yeah. Using y equals sine x, we're going to plug in 1. What is the sine of 1?
Zero, yeah.
You guys are going backwards.
It'd be 90.
You guys are, okay, so what you guys are answering, I see what you're doing. You guys are saying sine of what equals 1. Okay, that's not what it's asking. This does not say sine inverse. They're wanting to know what is the sine of 1. This is a calculator thing.
Oh.
Yes. This is a calculator thing.
You fooled us.
I know. Well, I get it. It's easy. The key is it's not where does sine equal 1. If so, I'd be good with thinking, okay, 0, 90, 180. You guys are on the right track there. But it's what is sine of 1? Kind of like what is sine of pi over 6? Yes, that's the number I'm looking for. So I'm going to do 4 decimal places worth 0.8415.
Yeah, 5.
Did you not say it? Did you not?
I think 4 slipped out. I don't know
Okay.
why, but yeah, 5.
Okay, so that was a calculator type dealy. Okay, so the point we're using is that. And the other thing you honestly could do at times is just write it as sine of 1. That is okay. So we found a point. Now what? Derivative. So the derivative of sine x is cosine x. Nope. Positive cosine x. And then what do I do with this? Put 1 into that derivative. What is the cosine of 1?
Another calculator.
A calculator. Good. He didn't let it get you this time.
Okay. 0.540.
Okay. And that cosine of 1, that is 0.5403. What is that? It's my slope. Okay. Now, when we think y equals mx plus b, there's a couple of different ways we can do this. Okay. One option is, yes, you can go straight to the decimals. The other option is y was 0.8415, but where did that come from? That was sine of 1. So there are times when they'll just leave it as sine of 1 equals m, which my slope was cosine of 1, times x, which x was just 1, and then plus b. Meaning, one thing you could do here is you could wait and do your decimals at this point, and so then b is going to be whatever sine of 1 minus cosine of 1 is. Okay? Yes?
So as far as plugging these in on my calculator, so you know how if you type in sine and then the 1, but then you also add a parentheses, it's the same as not adding a parentheses.
Mhm.
Is it ever going to be in a position where that is going to matter?
The in parentheses will matter if you continue going on past that point. Okay, it doesn't matter right now because we're not going on past that point. Does that make sense?
Yeah.
Yeah. So, and I'm fine with using the decimals here, but I just wanted you to see that you can also represent it that way. Okay. So the other option is if you put the decimals in, it's the 0.8415 equals 0.5403 plus b. Okay. B is 0.3012, and so y equals 0.5403x plus 0.3012.
Ain't too bad, eh?
Not too shabby.
Okay. Before we flip, notice it says higher order derivatives at the bottom, yes? What we have worked with up until this point is just taking the derivative, which what we've been doing is finding the first derivative. Okay? You can find technically an unlimited amount of derivatives. They're calling them higher order derivatives. So when we take the first derivative, it's f prime of x. If you see two little prime marks, that means you're taking the second derivative. If you see three little prime marks, that means you're taking the third derivative. Okay, so however many prime marks you see, that's the derivative you're taking. Now, to take the first derivative, you use the derivative rules once. To find the second derivative, you just take the derivative again. So you just keep repeatedly taking the derivatives however many times you need to. Yeah, derivative of the derivative. Okay, which means the rules are, I mean, if you're doing the rules we've done, it's not bad. So let's look at example 5. Now, so my original equation is let y equals 3u to the 5th. And then it says find d squared y over du squared at 2. So normally it would say find dy du. So if it says dy du, that's asking for the first derivative. Since this has the 2's in there, guess what? It's asking for the second derivative. The second derivative just means I find the first derivative, and then I find the derivative of the first derivative. So we just find the derivative twice in a row. Sounds hard, but it's not. So, let's start by finding dy du. In other words, let's start by finding the first derivative. If y is 3u to the 5th, do you guys know the first derivative?
4.
Good. We bring the 5 out front. 5 times 3 is 15. Subtract 1 to the exponents, u to the 4th. That's the first derivative. How do I find the second derivative? Take the derivative of what we just have here. So d squared y over du squared. What is the derivative of 15u to the 4th?
60.
Bring the 4 out front. 4 times 15 is 60. Subtract 1 of the exponents, u to the 3rd. Now, specifically, what did it ask us to find? And then it says, remember this bar says evaluated at x equals 2. Or in this case, it is u equals 2. So what do? Take our second derivative and plug in 2 for u. So d squared y over du squared evaluated at 2 means 60 instead of 60u to the 3rd, it's 60 times 2 to the 3rd. 2 to the 3rd is 8. 8 times 60 is 480. I personally think that's easier than the first part of the lesson. Okay. Example 6.
These lessons are going by really quickly. So.
Let f of x equals 1 over x squared. Find, can you guys read that? It's triple prime, yes. We are being asked to find the third derivative. Now, before we start trying to find derivatives, some of you guys were struggling with this yesterday, what should I think about my original equation? Yeah. The way to take derivatives is we need some variable raised to a power. And so 1 over x squared, if you bring it up, is x to the negative second. Are you guys okay with that?
Yeah.
So, f prime. So first derivative. Negative 2, x to the negative 3rd. He brought the negative 2 out front. He subtracted 1 from the exponent. If I was done here, I would put this into fraction form. Am I done here? No. So I would leave it like here and keep going. Second derivative. You guys okay with that? Negative 3 times negative 2 is 6. Subtract 1, x to the negative 4. Third derivative. Negative 24, x to the negative 5th. Okay. What did it ask me to find? F triple prime of 2. So now that I have found f triple prime, or the third derivative, we're going to take that and plug in 2. So this is negative 24. Wait a minute, time out. Well, okay. I'm going to backtrack for a brief moment. Negative 24, x to the negative 5th. What do you guys know about x to the negative 5th? To get rid of that negative exponent, take it to the bottom, right? Do not try and work with this in numbers because we can't do 2 to the negative 5th. So think of this as negative 24 over x to the 5th. And so now that I'm plugging 2 in, I should really think of it as negative 24 over 2 to the 5th. What is 2 to the 5th? 32. Negative 24 over 32 can be reduced if you choose to. Divide them by 8, and it's negative 3/4. I like basic derivatives. I like taking higher order derivatives because it's just doing derivatives. Okay? Questions there?
I'm going to make a sound with that derivative.
right now.
Google them, and you can probably find some already there. In fact, I know you can.